Truly an honor to be here. Thank you for coming. Welcome to a bit of a talk on infrastructure automation. We'll be talking about Terraform and Packer. We have a packed agenda and a short period of time, so let's jump right in. Get my clicker. To get started, I would like to start with a little bit of the developer experience enhancements that we've made with Terraform recently. Before I go there, how do we think about developer experience? Excellent developer experience is simplifying optimal solutions. So the best way to do something is the easiest way to do that, right? So without sacrificing maintainability, discoverability, legibility, right, of the code. So this has many implications across coding and infrastructure in general, automation in general. One of the new announcements that we want to make is around the CDK for Terraform, which is now generally available. CDK for Terraform allows developers who are familiar with programming languages beyond HCL to automate infrastructure using Terraform while having access to the entire Terraform ecosystem and toolset, right? The fact that it's GA now means that we are supporting it in production. It's production ready, and we're ready to support you as you embrace it and as you jump in for those use cases that involve any of these programming languages like TypeScript, Python, Java, C#, and others. Right? So encourage you to try it out, encourage you to put it on production, and let us know how it goes. We'll continue to invest in this and continue to make it better and better. Also recently, we released Terraform 1.3. And there's two components there that are worth mentioning. The first one being optional object types. This is really important for module developers who want to extend and iterate on those modules without breaking backward compatibility. So huge boom in the way in which you can iterate on those modules and provide enhancements for those users without having those users have to update their code. So by doing this, what you can do is provide new inputs or parameters that are optional, and by the way, also set a default for them. So no change at all in code, updates and new capabilities in the modules themselves, right? The next one is the moved block, which again, Armand talked a little bit about this, but we've been working on this for quite some time now. The idea being, we want to enable the refactoring of large code bases, specifically for folks who've been running and working with HCL and with Terraform for a long period of time, where those code bases tend to grow and grow. And this allows you to easily extract into modules, a very common pattern with any programming language. Take commonalities in the configuration or in the code and extracting them so that you can dry them up, right? Doing that in the past required developers to go into state file surgery, what we would call that, which is certainly not a recommended approach and actually quite dangerous. With this, it makes it quite easy to extract that and just tell Terraform, hey, what used to be called A or foo is now called bar, right? So there's no change in the actual infrastructure, thus allowing you to easily refactor. Let's go a little bit into the Terraform ecosystem. It still is mind-blowing. Every time we look at the Terraform registry, there's more and more providers being added by the communities. Last time I checked, it was over 2,500 providers. However, there's a few set of providers that are officially supported by HashiCorp. And we'll talk about some of the enhancements that we're making to the way we do that. But all these providers, not only do we partner with the cloud providers themselves, but we also maintain and build tooling to more easily maintain them and keep up to date. The goal being, when new functionality is available in the public clouds, we want to ensure that they're available to our users one way or another, and do that in a high quality way. Right. So speaking of that, super happy to announce a new tool called Pandora that is now open source. The URL is right there. It's under our HashiCorp GitHub. And the idea around Pandora, really, in a nutshell, is to be able to say, OK, Azure has these API definitions or a spec, and we're going to pull from that spec, import that, and generate a few things, right? What we're going to generate, essentially, is an SDK that can be used for a number of things, not only for provider development, but also we can actually generate provider code. And so what's important about this is that, because the feedback we've had has been that it would be nice to have new resources available as soon as they're available in the public clouds, right? So this just accelerates that and removes a lot of the manual effort of doing that. So now we can do that much quicker. We can do that in a less error-prone way, and we're super excited to make the tool available as open source. We encourage you to take a look and use it for your own uses and provide feedback. So super excited about this. We'll be generating actual resources. In the future, we'll see data sources. We have tests that are being generated on those resources in the actual generated provider code, as well as documentation, all pulling in from the live Azure API specs. So super cool. The next piece around provider automation or provider developer experience at the end of the day is around what we're calling the plugin framework, which finally made version 1.0 of the plugin framework. And what this is a much easier way to build providers for Terraform itself. So it's very idiomatic Go. So if you're a Go programmer, the constructs that you'll see in there are familiar. And that's just a huge developer experience boost. It's very flexible and extensible by design, very well documented, and essentially well tested, and the stable future of how you develop providers for Terraform. So if you're building new providers, or even have existing providers, we encourage you to try the plugin framework out and provide your feedback. We're in that process of doing that ourselves, of migrating some of our providers into the plugin framework and maturing it more and more. Next up, I want to talk about a really exciting new capability called workload identity. So shifting gears a little bit, it does have to do with developer experience, but this is ecosystem, dev experience, and security, right? The idea behind workload identity is that Terraform Cloud, the ultimate goal is to say, let's not store secrets, static secrets or long-lived secrets in Terraform Cloud, and instead move to a more just-in-time, short-lived secrets situation, which are not stored and are dynamic. So the integration with Vault allows you to do that because this is all based on standards. In this case, standard OIDC protocols allow you to authenticate with a trusted entity. In this case, Vault could be one of those, which in turn provides you with dynamic secrets that Terraform can use to authenticate with the public clouds or any provider that supports that is supported by Vault. But because it's a standard, Vault is one of the pieces that can support this, but this is actually supported by a number of providers out there. So it's super exciting to have this support built into Terraform Cloud itself. It'll generate a JOT token that then is used by the client to do this authentication dance. And we'll continue to iterate on this to make this completely seamless if you're a Vault user. And thus, just removing the need for static secrets and increasing security and the security stance in general of the Terraform runs. Super, super exciting capability. Next up is we actually implemented ServiceNow integration. So the goal here is how do we automatically track Terraform managed infrastructure in ServiceNow? We're pushing that metadata over to ServiceNow every time there's an apply in Terraform. So this now enables all these workflows to happen in the ServiceNow side of the house, knowing that you have the most current Terraform data or information available. Thus enabling new use cases, right? Super excited about this. It's now in beta, and we're working with ServiceNow very closely to continue to move this forward and make it available to all of our customers. Now jumping into looking at the challenges faced during day 2 operations. Okay. So speaking of governance, as a first piece here, one of the challenges that we've seen with Sentinel in general, Sentinel is great and the policy as code workflow works really well. But one of the challenges in very many customers is having to write policies themselves and maintain that over time. It's a challenge that many folks are facing. And so to address that, what we did is we published a set of foundational policies in the registry itself. And by the way, in this registry, you can also publish your own policies and share them with the community. There's been a few of you that have done that already, so super excited to see that. We intend to continue to grow the policy set and make those available and just learn from the customers and how they're using that. For those of you who don't know, the way policy works, it does a check between plan and apply, and it is able to either enforce or prevent an apply from happening, or just advise that something may be weird. Now, the company ethos, in some part, is about workloads, not tools, not underlying technologies. So when you put that lens on this, think about Sentinel, but you can also think about OPA. And so now we're introducing native OPA support in beta. It is essentially the very same workflow, and it sits in the same place as Sentinel, but it uses a framework that is open source called OPA, where lots of customers have invested on OPA or open policy agent support within their organizations. So providing this consistent, unified tool set for managing policies for Terraform and for other things within an organization is the goal. I'm really happy to say that this is now a supported piece of functionality within Terraform Cloud and Terraform Enterprise. And it has the same level of support as Sentinel in terms of the functionality, enforcement levels, policy sets, auditing, overrides, the same workflow. Quick screenshot of what that looks like. If you're familiar with Sentinel workflows within Terraform Cloud or Enterprise, this will feel just the same. If you're already a user of OPA within your organization, this makes a lot of sense. Otherwise, both Sentinel and OPA will be supported going forward. But in that place where Sentinel and policy sits, we also introduced the concept of run tasks. So this will look familiar to you. I just showed you a very similar chart or diagram showing where Sentinel sits. Well, the idea is run tasks, rather than being an internal native process that runs within Terraform Cloud or Enterprise, it is actually a webhook or a callback that goes out to a separate system where integrations can happen and processing can happen outside of that, and then have the same level of control back into Terraform itself. So similarly, with a run task, it is possible to prevent a run from happening or an apply from happening, or just advise, right? Based on that response code and then the payloads that are available, right? Now, what we've done recently, up to now, we've provided post in the phases of Terraform itself, just a post plan run task. But what we're doing right now, and announcing today, is pre-plan run tasks as well. And what I'm excited about here is just being able to perform actions before the plan is even generated. So at this point, there is no plan. And by enabling this functionality, you can actually do checks on the code itself. So what kind of analysis can we do on the code, whether it's linting or fishing for secrets that shouldn't be there, or anything like that, that you can actually prevent the plan from even happening if you integrate at this stage, right? So any checks on the configuration itself will be placed in the pre-plan run task. And similarly, there's a pre-apply run task now available, okay? And this addresses potential time gap between plan and apply. A plan could happen hours before an apply happens. And so what would you want to check there? Well, I think about, what about checking if we're in a maintenance window right now? You hit some API endpoint, or maybe you do a health check, and you ensure that you can actually proceed with the apply the moment it's about to happen. So it now opens up another set of workflows just by building a simple service that takes an HTTP call and responds appropriately, right? So I'm excited about the capabilities that are enabled by enabling you to hook into the system in all these ways and just write custom logic and build kind of use cases that even we haven't thought of yet. So super excited to see what you do with that. To recap, we released drift detection a few months back in Amsterdam in HashiCorp EU. I'm excited to say that it's now generally available. It was a beta release, and now it's GA. Thousands of workspaces have been enabled for drift detection, and super excited to see the adoption that we've had. The underlying system that works with drift detection essentially is this loop, right? We provision infrastructure, and then we're in this loop of saying, let's check, let's detect something, and then let's notify. And that notification could be a Slack message, an email, all the common notification pieces, but also, interestingly, webhooks as well. So similar to run tasks where you receive a webhook, you do some operation, and then you respond to that. Now you can actually start automating remediation as well. Super exciting. As far as the check and detect, so far that's been, hey, let's check and detect drift. Yeah? And when we detect drift, we'll send a notification. But we're continuing to build on this framework. The framework is solid, scalable, performant, and can be used for many, many things. So this is the kind of foundational technology that we've built that's going to allow us to continue to evolve and grow the capabilities of the platform itself. Now, to talk and build up to that, I'll set some context. In Terraform 1.2, we introduced the notion of pre and post conditions. Post conditions are essentially, I want to do some assertion about the infrastructure at the time that you're writing that infra. You can make those assertions, and when Terraform is actually running through the plan and the apply, it'll check them, right? If it's a precondition, it'll prevent the resource from being created or for that code from being evaluated. If it's post, it'll do that afterwards, right? Now we're happy to announce continuous validation in public beta. This is, again, it does the same loop, the observe, detect, notify loop that we're talking about with drift detection, but what we're checking is these post conditions. So now any arbitrary code or any assertion that you can write in ITIL will be checked continuously by the platform. So here's some of the interesting things that we've dreamed up of and made available as examples. So post conditions with continuous validation, right? What does that look like? Here what we're doing is, will the certificate expire in 90 days or whatever it is, right? So here what we did is we said, we added a function ready for renewal to the provider itself. So when you're provisioning a cert, you can ask, is this about to renew? In this case, it's in 4 hours, right? And of course, when you're provisioning that certificate, it won't be 4 hours from expiration, but at some point it will. And most of us have had the experience of having a certificate expire and having large, widespread outage as a result, right? So this will kind of prevent that kind of thing. I think this idea of checks on infrastructure that changes based on the time of day, basically, or changes as time goes by, are really good fits for this, right? Another example of this is checking the root token for Vault, right? I've had conversations with folks where the massive outages just because a root token in Vault, which is central to the infrastructure, expired. And there was no monitoring for that, and it took hours to even understand what was going on, right? So what's beautiful about this, I think, is that when you're provisioning that infrastructure, you're thinking about the conditions, and we'll just check those for you, right? So really excited to see continuous validation made available. As you can see, it's a very flexible system. Really excited to see kind of what you can build with it and where we take this. Yeah. There's a few enhancements to ATP Packer as well. To recap, Packer is for building deployable artifacts, right, in a consistent workflow. ATP Packer tracks those artifacts for you, and then layers on workflows that you can build on top of that. A common way that we use Packer and many folks use essentially ephemeral infrastructure in general, is to provide a base image within an organization and then pass that image along to the various teams. For example, a core infrastructure team might build a base image, pass it along to the security team. They may add some scanning, they may add some agents, or otherwise harden that image, right? And then that gets passed along to application teams, who in some cases even add their own code and their own data, to make that a deployable artifact. So now that you've gone through multiple iterations up to the point where you're adding that code, well, you've created a problem. How do I actually know what's out there? Like, which base image is deployed where? And if there's an issue with that image, how do I know which images I need to rotate, right? So it's not only in this example, the billing app team is using that base image, but also even a marketing site, maybe using the same image. So how do you revoke those or just track them over time? And that's where ACP Packer comes in. Okay. Some of the pieces that we've built in the last few months specifically has been ancestry tracking, which is a little bit of what we're talking about. So now the UI is going to tell you this base image has all these children. Once you revoke the top level image or artifact, you can actually know which of those child images and where they're deployed and where that vulnerability may exist within the infrastructure. And so those workflows around revocation and tracking is what we're trying to look at. Promotion history is another good example of that. You can see how images get promoted from, say, a staging environment to a production environment and track all of that. And finally, we introduced the idea of a latest channel. It's just an automatic, magical, kind of behind-the-scenes channel that always contains the latest image within the system. And this is extremely useful in the context of Terraform, because now when you're provisioning infrastructure through Terraform and describing which image to use, I've heard all sorts of things and been doing that myself over the years, where when you want to update an image, you need to actually go into the HCL code and modify a string which has an ID for the image that is now the latest, right? Well, that's over. Now you write that code once, and you want to flip from v-1 to v current of the image or the artifact, and that automatically is wired up, because the integration between Packer and Terraform allows for that. And by the way, the example that Armin had earlier was doing exactly that, but then using continuous validation to say, am I running the latest? And if you aren't running that latest, you'll get a notification. So now you can actually go revoke, and you can actually take action. Right? So it starts all fitting together. Quite nice, you're right. Now, when we talk about day 2 operations and issues, these are some interesting stats to kind of have as context. 21% of companies have security events due to non-sanctioned IT. This is the Wild West where I just click through things and provision infrastructure, and here we go. And then all of a sudden, that's production. And years later, it's not tracked and kind of unknown, right? 65% of cloud security issues start with misconfiguration. It's a very common issue where we provision the infra, but we are not experts in that. We're application developers. I know how to write Rails code, not infrastructure. So make it work is kind of the mentality. After that, we end up with this misconfiguration situation, right? So there needs to be a layer of governance is the point of that, right? And 30% overspending with minimal cloud cost optimization strategy. Removing the need for these ad hoc, non-sanctioned IT situations and providing really awesome workflows around provisioning infrastructure inherently means that you're not going to over-provision or lose track of infrastructure that's actually running out there, right? But because of all these things and many more, scaling infrastructure provisioning and automation within an organization is actually quite hard. There's a number of issues related to that. Many of which are related to what we just talked about, right? Application developers scale way faster than platform teams. The platform team being the central DevOps team or platform organization or cloud center of excellence. There's all these names for it, but this central team who actually know about infrastructure is very small relative to the rest of the application developers within our organization, and over time it gets worse and worse. So we need to find ways to provide leverage there. Otherwise, it just won't work, right? Cloud infrastructure itself is evolving. New tools are made available, so the best practices and the way to deploy infrastructure is kind of an ever-evolving and dynamic, scary world, right? But platform teams and infrastructure folks know that and are on that all day, versus a Rails developer who isn't and shouldn't, frankly. So how do we enable them, right? It's really hard to set things up. Security gaps everywhere. And this is the killer. Platform teams are usually in the critical path. You want to onboard a new developer. Either you've beautifully automated that onboarding and they can self-serve everything, that's the dream, or you're going to get a ticket or a Slack message or something saying, I need to deploy this thing, where do I start? And that just triggers days worth of setting up systems and provisioning and enabling those teams, right? It's actually quite a big issue. The skills gap gets worse every day. So how do we enable those app developers? We're introducing no-code deployment workflows. So the idea here, and I'm going to rush it over because I'm running out of time, so apologies. But the idea here is a platform team will define the best practice as a module. They'll define this module is no-code deployable. And application teams may use the UI to deploy those modules. So now the best practice is ingrained in the module itself by the people who know and understand infrastructure the most and are making them available to the rest of the organization in a very seamless, easy workflow. So those folks don't really need to even know Terraform to be able to be empowered to deploy their apps and be successful in their roles, right? So that way we can scale to thousands of developers within our organization in a safe way, providing enablement while also providing governance over that. Apologies, I'm going to run over by a minute. Just a quick run through. Platform teams add a module. A user can filter down by no-code ready modules, and those are the modules that are deployable through this workflow. They pick one, and the top right, they say, provision this to a workspace. They click on that. The author of the module has defined a set of parameters, so you can see configure module inputs on the left there. You set those, the user sets those parameters, that's all they need to do. Then they configure the actual workspace where this is going to land. Give it a name, give it a description if you want, scroll down, hit create workspace, and now you're in Terraform, and Terraform does its thing, provisions that for them, right? This is a really strong way to now start scaling infrastructure provisioning in a safe way within the organization.